Hopefully.
Yes, hopefully.
It's pretty embarrassing if you don't test the initial state.
And this is beautiful. This is absolutely beautiful, right? Because I can look at the code and the code is always clear.
This is like 10 lines of Go code, all standard library.
Immutability is going to give you, I can argue that confidently, is going to give you better software maintenance because it's going to make it much clearer to understand.
Today I'm here with José Valim, and I'm butchering the last name. Can you say it correctly for everybody listening?
Yeah, José Valim. And it's funny you say that because usually people, they go in the comments and say, it's José, it's Portuguese, right? But I honestly, I don't mind.
José Valim. And the funny thing is, I knew that, and it's still like, I speak Spanish, it still destroys me. Like, I don't have the mental capacity to go 2 language hops, like through Spanish all the way into Portuguese. So
when I was in university, I studied French and English at the same time. And it was horrible because I would go like to the English classes and suddenly say entertainment, right? Like suddenly like the French word, some French sounds would come up to my head and completely mess everything up. So could not speak any of those properly.
Okay, I've had a very similar experience, I think, and it's terrible. So living down in Paraguay, speaking Spanish, I came to kind of associate people not understanding me with like, oh, I need to tell them in Spanish. Especially like when I was new there, because I'd like say something in English forgetting, and they'd be like, I don't understand, and then I'd like try to think of the Spanish word. There have been a few very embarrassing times when I've been like speaking to a Japanese person. And then I'll be like, oh, you don't understand. Let me tell you in Spanish. And I just like start, and I'm like, oh my God, like, what am I doing?
yeah. If you're going to embarrassing stories, I can contribute one as well. So I live in Poland, right? And Ola is a Polish name. It's a shortcut, I believe, for Alexandra, but people introduce themselves as Ola, right? But if you speak Spanish or Portuguese, hola is a greeting, right? So you can see where this is going, right? Like my wife was introducing me to her friend, right? And then she's like, oh, hello, my name is Ola. And then I'm like, Ola, like repeating the name all the time, right? People are like, why is he repeating my name? Until like 1 weekend later, you're like, oh, Now I know I didn't get her name. She was not greeting me.
That sounds exactly like something I would do. What a struggle. Cool. Well, today, so for everyone who didn't already pick up on this just by me name dropping you, today I'm speaking with the creator of the Elixir programming language, which I was doing some research. Elixir is, it's a popular language. I don't want to not do it justice. It's not JavaScript. It's not Python, but it is a popular language. And it really kind of blew me away to find out that it's arguably the most popular functional programming language used in industry. There's some contenders, but Elixir is really up there when I was checking the Stack Overflow survey. I'm sure you're happy with those numbers.
Yeah. Oh, I think just in that quick stat, there's so much we can talk about, but I think like depending on the metrics that you are looking at. So for example, like there are metrics from like the GitHub statistics, like number of commits, pull requests, and Elixir is usually like top 3. We are kind of like between, sometimes they are above Scala and Haskell. In other metrics, they are above us. Which is definitely very interesting. But one of the things that it's curious to me is that when people think about like functional programming languages, or they would describe it, like Elixir or Erlang is not necessarily what comes to mind, right?
Yeah.
So it's a funny, curious place to be at, I think. Yeah, the Stack Overflow, I don't believe it was the most popular. It was the most loved or most admired. Yeah.
Yeah,
and that
let's
was
show that
pretty,
one too.
Second most loved, second most admired. Oh, but you're saying like in the Stack Overflow, it also came as the most popular between the FP ones?
Yeah, so obviously, like, if you cut down to the FP languages, which, like, takes it down pretty small, admittedly, like, Scala is the only one I'm seeing that, at least that I recognized as a functional language, that comes in just a, like, 0.3% higher than Elixir. Elixir's sitting there at
Okay.
2.3% usage amongst professional developers.
Oh, I actually, so that's news to me. I actually did not look at that part of the Stacks
Oh,
Overflow.
really? Okay,
Yeah,
cool.
yeah.
Yeah, I was blown away. Like, it's got, I mean, if you compare it to, say, OCaml, which is something for some reason, like, we hear about it all the time. I've had like 5 people on this podcast talk about OCaml. It's at 0.5% of usage amongst
Okay.
professional developers. Elixir's like 5 times that, according to Stack Overflow.
Yeah, yeah. And then I know we got most loved or admired, the second most loved behind Rust. And
Yeah, which is crazy impressive, by the way.
yeah. Yeah, and then there is we can talk a lot about that as well. And then there is also I think the Phoenix Web Framework came as which is how we build web applications in Elixir, and that one came as as first most loved or most admired, which is really really nice.
I haven't done Phoenix, Elixir Phoenix yet. I am very curious. I've always been critical of like full stack web development frameworks. Like I said, I have not tried Phoenix, so it's absolutely not fair for me to like lump it in with the others. But like I've always been very critical of Django Python. That's the one I've had the most experience with. And then I've always kind of unfairly lumped Ruby on Rails in with it because I know they're similar. Again, I know they're not the same. They're similar because I'm such a Go fanboy minimalist. That I've always struggled with the frameworks. Actually, that brings up an interesting question. How much, like, obviously you created Elixir, you've done a lot of Elixir, you've done a lot of Erlang. Do you do much with Phoenix in terms of using the framework?
Yeah, so it's definitely, I would say it doesn't consist a huge amount of my time, but I definitely do it. So I'm working on a product, which is obviously using Phoenix. We have this amazing tool called Livebook, which is like Jupyter, trying to summarize like Jupyter notebooks, but for Elixir, but with a bunch of different takes into a bunch of things. So like distributed programming is part of the whole infrastructure. And that like Jupyter notebooks is like, it's a web application. So it's built with Phoenix as well. It's also built with LiveView, which is this tool that we have in Phoenix for writing, client-side applications as well. How would I say? Well, you want to write like a full stack application, but you don't want to be split into writing JavaScript, right? And then going and writing Elixir. So you want to have tools that unify the front end with the back end, and Phoenix LiveView, it's one of the first actually libraries to do that. And it does it with a very unique, Phoenixy, Elixir approach, which we can talk about as well. So I do some, but it's not like the bulk of my time. I usually prefer to be like 1 or 2 layers below that.
Yeah, I would imagine as a programming language author. Okay, you mentioned this idea of Elixir-y, Phoenix-y, and I want to start to jump into that because a lot of the listeners of this podcast, especially if they were around for season 1, they probably heard several episodes on the topic of functional programming. And one thing that always came up was like, oh, for it to be functional programming, it has to have this beautiful Hindley-Milner type system, right? And that is the true essence of functional programming. But I was blown away to discover, because I'd always known of Elixir, at least in my mind, as like, oh, this is like one of the more popular functional programming languages, particularly for web stuff, not statically typed.
No, it isn't.
Tell me about that decision.
Yeah. So that decision pretty much came from, it didn't come from me. We may need to have a 3 hours episode, but since like this is just the discovery, there are so many topics, right? But so Elixir runs on top of the Erlang virtual machine. And the Erlang virtual machine was created by Ericsson, which is a telecommunication company. And the lab, the team, like who built Erlang, the language and the runtime, what they had to do is to build telephone switches, right? So a telephone switch needs to deal with concurrency, a lot of people talking at the same time, right? It needs to be able to deal with distribution, right? Because it's literally a global network. and it needs to be able to deal with fault tolerance. You don't want, like, if something goes wrong, that system needs to recover itself, right? It's basic infrastructure, right? And there are even other requirements, like you need to be able to upgrade the code live in production while the system is running, right? Because it cannot be like, oh, just do like a blue, green, or whatever deployment where you go and shut everybody off and then you start again. Because, there's always going to be somebody on the phone. You cannot like just
Everyone's telephone calls just end.
Yeah,
like,
just
okay,
end.
Call them back.
Yeah. I also like to say, like, we don't receive like messages from our phone operators saying, hey, the system is going to be in maintenance mode from 2 a.m. to 3 a.m. Please don't do any calls, right? So they had to solve all those problems, and they came with Erlang, right? And when they did that, so it was like very pragmatic, like problem solve driven. Like, so people are going to say Erlang has the actor model, but like when they created Erlang, they did not know that there was this thing called the actor model. It just turned out that for the kind of fault-tolerant, concurrent, distributed software they wanted to build, the actor model, which they didn't know at the time was the actor model, that kind of solution was what they wanted. And then they say, like, look, if we thought a type system would have been helpful for us to write this kind of fault-tolerant software resilient, we would have implemented a type system, but we just don't think that was the essential part of it, right? And then if you tell this to people, right, some people are not going to be happy with that at all, right? But if you get from their point of view, right, like it's literally a distributed system running over the network. You cannot model like all the states that can go wrong, right? Like sometimes like, like a bit flipped, things went wrong, right? Like the whole thing disappeared. The other node is not responding. How are you going to deal with this? So they realized that the important thing to have in that system is if something goes wrong, the system needs to be able to heal itself and recover and go back to a working state. And that's what they worked on. And we can talk a lot about what makes that possible. But that was their focus. I think like today, so when I came with Elixir, I was coming from Ruby, a dynamic language, and then I was like, all right, Erlang is dynamic, Elixir is going to be dynamic, and I was happy with that decision because that was my background, that was where I was coming from. But today I have been for 3 years, I think, at this point, working with the CNRS, which is like the largest research institution in Europe for bringing a type system to Elixir. And I have been working on those problems. And I think there are a lot of benefits that we can get from a type system in finding some class of bugs and in make sure that we get feedback quick. But I have to say that also the benefits of a type system, they tend to be like overblown, right? Like what you hear, the things that people say online about type systems, like, like, like if I have a type system, I can write fewer tests. For me, it's like, no, like that should not be the case. Like maybe you can write fewer bad tests, right? Maybe. Or maybe if you're using like a language like JavaScript or PHP where you have weak typing and kind of anything goes. But for the huge majority of languages, that's not going to be true, right? Because types, they are representing types, right? Like your code is all about values, right? So I like to say, like, if you take like the Boolean OR operation, right? Like if you receive false and false returns false. If you receive true and false returns true, and so on, right? The type of that thing is receives a Boolean, returns a Boolean, which means an implementation that returns true or false randomly would completely satisfy the type system, and it would be obviously wrong. So yeah, so Elixir is, the long story short, Elixir is a dynamically typed language. We have been researching and bringing a gradual type system into Elixir. And a lot of people are going to think, oh, TypeScript. TypeScript is the closest thing, but what we're working on is quite different from TypeScript in many ways. We have a lot of things in our blog explaining our design decisions. But yeah, I think today it's still very fair to say that it is a dynamically typed language.
I don't want to get into a discussion about whether static or dynamic typing is better, because I do sit pretty firmly on the side of really liking static types. And I would even go so far as to say, I do believe that static types can eliminate a lot of unit tests that you would otherwise need. But I'm sitting here with the creator of the Elixir programming language, and I feel very outclassed. And so it's not even a discussion I want to get into. People have heard my opinions on static types before, so I won't like shy away from my opinions. But it is pretty intimidating to be like, oh yes, you've created a programming language. I've shipped a few web apps. Why don't I tell you how to write? Why don't I tell you how to write some code? So I'll encourage people to do their own research on that. Plus, there's a lot of really interesting stuff to talk about the concurrency model. So I don't want to get too far into it, but I'm really excited to hear that you guys are thinking about types, because, okay, maybe I'll say like a couple things, and I'll ask you a question about it too. When you were talking about the Erlang folks, which I know that we don't have any of the Erlang creators here on this call, so we can't speak for them, but we can maybe suppose what they were thinking or guess at it. You said something that I thought was really interesting, which was like, okay, when they were designing Erlang, they were more worried about, and I'm paraphrasing you here, they were more worried about like faulty stuff happening almost at like the hardware level or at the network level, right? Like I'm receiving maybe payloads over the network that are invalid, and I need to parse and check those and make sure that they're valid. I'm worried about like nodes not being able to talk to each other. I'm worried about one part of the system being down. And that it's almost like that class of problem was so large that it just completely dwarfed any issues with like, oh, I forgot I was supposed to pass in a string here instead of an integer. That like what's happening in my code just wasn't as much of a concern, because I have to worry so much about what's coming into my system almost as like external inputs. Is that kind of what you were thinking?
Yes, I think it's a lot about that. So for example, like in the process of adding types to Elixir, we have to think a lot about our idioms, right? What we want to do, what we want to express, right? So one of the things is that, like, imagine that you're calling another service, right? And imagine that there is a well-defined contract between those two things. And what happens if for some reason, can be anything, two different services running over the network, it sends some data that does not adhere to your contract, right? To what you're expecting, right? Like there is like, what can you, like, it's not something that like, it's something that you can model. But after you model that, exactly what are you going to do? Like you can think about things like, oh, probably the best thing that I can do is to drop what I'm doing, because that's an important partner for my service. It's clearly saying gibberish. It's clearly saying something that is not part of a standard. So I should probably just like assume that whatever I have done this far is not good. There's something going wrong. I should probably start again.
Yeah.
So that's the things, those are the kind of idioms that they established, right? So wait, something unexpected is happening. And again, it can be a separate service. Maybe it can be a hardware component that uses radio that they need to handle in the system or whatever. I don't know much about telecom, right? But anything that your system needs to interact to, right? Which is what a lot of us are doing every day in the web anyway, right? We're all talking to APIs, database, all those kind of things. So they think about, well, something went wrong. How can we recover to a working state? That's the question they wanted to answer, because that's the thing, right? Because one thing that you can say is, well, maybe the fault is on the separate system, right? And then I'm going to retry. But maybe the fault, it was a bug in our system. For example, if you're talking with something in the network, imagine if somewhere you accidentally read 1 extra byte of the socket, right? If you had read 1 extra byte of the socket, everything else that socket sends to you is going to appear clear gibberish, right? So the error is not the separate system. The error was a bug in your system, right? Which, can happen. You can accidentally read more than you want. That makes everything go crazy. And then if you're like, oh, I'm just going to retry. Yeah, retry. Unless you're like, oh, I am restarting the whole connection and setting up everything again. Like, if we just say, I'm going to do the request again, it's not going to fix that, right? So that's the thing. Like, if you really think like, well, what are the kinds of things that can go wrong and how much of those we can model with type systems? Like, like there is a huge, like there is a lot of things that are going to overlap, but there is a lot that is you're not going to be able to do that, right? So they're like, look, the most important is for us to have a mechanism where if something goes wrong, we can put the system. It doesn't matter if it's a separate thing. It doesn't matter if it's a lost state, a state that was corrupted. The system can go back to a working state. And that's why we have like supervision trees, right? So we build everything on top of that. Like, so we organize our code into like processes. So like throughout this podcast now, whenever I say process, I mean, like, I do not mean an operating system process. I mean a very cheap, lightweight thread of execution, like a Goroutine. So we organize all of our code, like in those processes, in those Goroutines, where they are completely isolated from each other, right? They do not have shared state, which is very important because if they have shared state and something goes wrong, and if something goes wrong because of that shared state, you just corrupted the whole system, right? So their whole design principle was, how can we write software that things are isolated, and when a crash happens, the crash is going to be isolated to that part of the system and we can restart it. Which again is not really much different than how our operating system works, right? Like the programs, the operating system process, they are all isolated, and when something crashes, it should not affect the other one, right? So there's a lot of similarity in there, but that's what they were going for.
Yeah, that makes sense. I mean, type systems to me help me primarily with my own and my team's own skill issues regarding like just passing data throughout a program. And obviously I come from the context of web development. So like, for example, in Go, work with the network a lot, but usually what happens at the network boundary is like we get a payload and then we unmarshal it into some in-memory structure. And so it's like at that moment, like that is where all these problems can happen, right? If the data is garbled, it's not going to unmarshal. It's going to fail to unmarshal at that point and I'll get an error. But in theory, at least, once I've unmarshaled into an in-memory structure, like now my type system can somewhat keep me safe as I pass that data throughout my program and in and out of functions and things like that. But like at that network boundary, it doesn't really help other than to like ensure that it's in the proper state. And to your point, like I usually design these types of web systems to just like fail outright. Like, oh, the data's a little bit off. Screw it. We'll just log an error and we'll blow the world up and it's not going to work and we'll just fix it. It'll show up in our logs and we'll fix it. But that's not acceptable in other types of systems where you can't just like hot deploy, 20 minutes later once you see the error show up in your log. So I totally understand that like in some systems, that's the whole problem. Like that's the 80% of the problem. And I'm kind of just hand waving it away and being like, well, I'll just throw an error right there. So it makes a lot of sense to me that they had bigger concerns almost, or at least different concerns.
Yeah. And again, like that's only one aspect, right? But there is also like, they are building a distributed system. How you're going to deal with typing in a distributed system. And also they have like the hot code loading. They want to change the code live in production while the system is running. How does types play into that as well? So from their point of view, they were like, look, and one of the things about Erlang is that the amount of observability that you get into the system is amazing. Is like, so for example, like I think a lot of the audience is like Python developers and Go developers. I'm going to make like a lot of comparisons to Go because I think they are closer, but like because all the code in Elixir and Erlang runs in their own process are kind of equivalent to Goroutines and they have their own state. We actually have tools that allow you to jump into the system, into a running system and say, show me how all the processes that are running right now. So you can go for all the processes, see how much memory they are using, and their state. Like, it's an insane amount of visibility that you get into the system. And because the processes, they communicate by sending messages, they have an inbox, which is where the message is delivered. So you can actually go and see the process, how many items they have in their inbox and what are those items. So from their point, and this is amazing because, for example, like sometimes when we're doing optimizations, like, oh, there's something going wrong in the system. Like, I literally multiple times solve bottlenecks by just saying, list me the process which has the most entries in its message queue. And I was like, oh, this process has 200 entries. It's a bottleneck. Boom. I go and I solve the problem and I continue with my life. So like from their perspective, like, look, we are thinking about distribution, hot code swapping, a system that can heal itself, a system that should come with a huge amount of introspection and visibility into it, right? So it's a dynamic system. So when you rank all those other things that they needed, right? Like, sure, like, are they saying that type system is not important? That's not what they are saying, right? But they are saying, like, from the things they needed, their priority list, the type system was not at the top, right?
Yeah.
And the other thing is that, like, as we work on the types for Elixir, like, first thing, the type system they are using is something called a set theoretic type system. And research on those kind of type systems only caught up it's like 2 decades ago. So it's relatively recent as far as it comes to theory, right? Like, they are like important researchers that tried to add type systems to Erlang in the past. And they could not. They failed because of how the language is. So like the one they're adding to Elixir is not only is relatively recent, it did not exist when Erlang was created, but even in this process, we are actually like writing new theory, so it supports the Elixir type system. Like literally, like the theory that
crazy.
existed before is not enough to type some of our idioms, right? So it is. And we're not even going into like the parts like that talk about like the concurrency aspects and the hot code swapping aspects. Like I'm working on something that is related with upgrading code live and how we can model that with types, but it's like it's new, it's fresh. There is not a lot we can like lean into. So I think like when you consider all those things, right, it makes a lot of sense, the trade-offs they made and how they prioritize those. And I am definitely not capable to be, if I went back in time, I would definitely not have the credentials to enter the laboratory that created Erlang. They would leave me out of the door. But if I was there, I would probably like agree with them. Like, yeah, no, it makes total sense. Like I'm not worried about types right now.
Very cool. Okay, I want to shift gears a little bit and talk about Erlang, Beam, VM, Elixir, and in particular, like you said, comparing it to the distribution model of Go. So to set the stage a little bit, let me catch the audience up just a little on some of these key facts. So Erlang, as you said, language developed for telecoms. The Erlang code is, and correct me if I get any of these details slightly wrong, the Erlang code is compiled to a bytecode that runs on Beam, which is the Erlang VM. And it's designed like at the language level, which is so cool to me. It's designed to run as a distributed system on multiple machines, which like I'm not familiar with other languages that do this. Like Go is a highly concurrent language. It's designed at the language level to be concurrent. But like if you want to build a distributed system in Go, like the language doesn't have primitives that span machines. I'm still writing, my own code essentially to handle all of that stuff. And so that's something that's like really unique about Erlang. And then Elixir is a different language, but that uses the Erlang VM Beam and takes advantage of all those primitives. Am I doing all right so far?
Yes, that's perfect, right? So just one example, like the same way you have the Java VM, it runs Java, Scala, Kotlin. You have the Erlang VM, runs Erlang, Elixir, and other languages.
Awesome. What are there any other like major languages that run on Beam, or is it primarily just Elixir
I
and
believe
Erlang?
I think the other two that would come up is Gleam, which does have like a Hitler-Milner type system, I believe, and LFE, which is a Lisp flavored Erlang. So it's a Lisp running on the Erlang virtual machine. I think those would be like the four main ones.
Got it. Okay, cool. Let's talk about then this idea of distributed distributed Elixir on the Erlang VM. So again, just to catch up the audience, so in Go, we have this idea of Go routines, which are essentially lightweight threads. So where you can maybe have, I'm going to butcher the numbers, but like, hundreds to thousands of operating system threads. You could have millions of lightweight Go routines. Go routines sort of multiplex over operating system threads. And the whole point is, when you're working in Go, you don't really think too much about operating system threads. You mostly just think about Go routines. They're highly concurrent. And when you need to communicate between Go routines, you have two options. You can share state between Go routines. So like maybe a shared map in memory, a shared struct, pointer to a struct. And then you'd use like a mutex, mutual exclusion lock, so that the individual Go routines don't access the same memory at the exact same time, like corrupt stuff. That's like one option. The preferred option actually is to use the Go primitive, which is channels, essentially pass messages safely across Go routines. Like one Go routine could be publishing into a channel, like, hey, I did this work, I did this work, I did this work, and another Go routine could be listening on that channel, be like, oh, I see that this work was done, now I'm going to do my work on top of it. What is the Elixir equivalent to essentially Go routines and channels?
Yeah, perfect. So in Elixir, we have those things called processes, which we're talking about. Can also create millions of those. They're also multiplexed over the operating system threads. So very similar. I believe Goroutines, are they fully preemptive today? They were not at the beginning. I know they slowly add preemption on top. I don't know at which stage it is today. But in Erlang, the process, they are fully preemptive. They all get.
Can you explain what that term means?
Yeah, so preemptive means that maybe I cannot, but I'll try.
Yeah.
So preemptive means that I think the simplest way to say that is that they cannot run forever. They can only do some amount of work, and then they are automatically scheduled out for another process to run. So it cannot do a starvation, cannot have. So I know Go at the beginning had this, like a Go routine could just not send something through a channel or something like that. So it would run forever and not give the opportunity for other Go routines to run, because at no moment it could like give somebody else a turn.
It's like if it's hogging the CPU, it could just like keep hogging the CPU.
Yes. So operating system processes, they are preemptive as well, right? They cannot run forever. They are going to get some amount of work, and then the operating system process like, all right, you did too much. It's time for somebody else to run, right? So the preemption, there is a proper formal definition, which I'm not going to recall right now, but that's what it means. I'm not
sure about Go, is what I would say. I know that like in practice, what seems to happen is if I have a bunch of Go routines reading off of a channel, they seem to like round robin the work. But
yeah, they will definitely preempt around the channel. So when they like need to wait for the channel, they will preempt. And I know over time, they allowed like other things, other operations to preempt. So for example, maybe when they send a message, we could see if we should preempt and allow somebody else to run. I'm guessing. But I know like with time, they added more opportunities for a Go routine to say, maybe I should give my turn to somebody else. Right? But I don't know.
More fluidity. Like there used to be probably more Grug-like locking. Is that, and it's probably gotten better over time. Is that?
Yes, something along those lines. I'm not saying with 100% confidence, but I know that Erlang is 100% preemptive, right? Like the process will eventually give its turn. So one of the examples that I like, so when I mention preemptive, the way I like to explain it is like gas. All processes get some amount of gas, some amount of fuel, whatever you pronounce that.
Fuel, yeah.
Yeah, I just had to recall the Metallica song to think like, yeah, so give me fuel. Anyway, yeah, fuel, and then they use the fuel, the gas, whatever, and give the turn for somebody else to run, right? So it's preemptive. So that's so when it comes to that to concurrency, that's one of the first differences. And the other thing is that we don't use channels, we use actors. There is like some research that say like they are actually duals of each other, right? But the idea is that you don't put a message in a channel and then somebody picks up, is that you send a message. So each process that you create has an identifier, and you send a message directly to that process, which has a message queue, and that goes into the message queue. So that's one of the important properties here. Like we are sending messages to something in a particular, a given process. And the important thing is that the way that the runtime that the Erlang virtual machine works is that when you send a message to a process, it doesn't matter if that process is in this machine or running in another Erlang virtual machine in the cluster. The message passing is going to work transparently. And all of the concurrency primitives that we have work like that. So for example, we have those processes, you can actually monitor a process, because maybe you want to say, hey, if that process crashes, if something goes wrong with that process, I want to notice that and do something about it. So that's how a supervisor would work. The job of a supervisor is to know how to restart the system. And then if one of its children terminate, it's like, oh, I can see that this part of the system went wrong, so I'm going to restart it again. And that's a lot of the fault-tolerant principles in the Erlang virtual machine. It's just starting over, right? Which is something that we do all the time, right? Like, oh, my printer is not working.
Classic IT meme.
Yeah, right. It's
yeah.
Right. So that's like codified. Have you tried it? Have you tried turn it on and off? Right. Like it's the codified thing. But why does it work? Right. Because when you restart the thing, you go back to the initial state. The initial state is the one that you tested for sure. Is the one that when you push to staging, that's the thing that you tested.
It's the only one that you tested for sure. Right?
Yes. Yes. Maybe, right?
Hopefully.
Yes, hopefully.
It's pretty embarrassing if you don't test the initial state. Yeah.
Yes, hopefully.
That means you didn't test any state.
Yeah, so, it's... So those are, we start seeing the differences, right? So it's like, now we have processes, they can send messages, between them. It doesn't matter if it's in the same node or in other nodes. And we have primitives, right? For like, hey, has this process gone down or not? That also works for concurrency and distribution, right? So those are the difference. There's more that I can talk about, but I'm going to pause and do a checkpoint with you. Yeah.
Yeah. So, okay. I have a few questions about the distribution system. Going to talk about in a second. It sounds incredible and very different from what I'm used to. Before we do that, you mentioned something really interesting that I just want to follow up on and make sure I understood properly. So when processes are communicating in the Erlang VM and in Elixir, it sounds like one process can send another message to another process by like explicitly using the ID of that process. In other words, if process, let's just say 12 wants to send a message to process 17, it would like explicitly say, I'm sending process 12 needs to be aware of process 17. Say I'm sending to process 17. That's really interesting because like I would consider that to be a model that's like, I don't even know what the name is. It's like a push system. Like I'm pushing a message directly to a specific recipient. Whereas like Go channels, for example, are much more like pub subby in the sense that like you just publish to a channel and you actually don't know who's on the other end. And maybe it's multiple Goroutines listening. And so you just kind of send it off into the ether and like hope someone's listening and picking up that message. Is that an accurate distinction? And is there kind of a built-in way to do the pub sub, or is that something you build on top of to get working in like Elixir and Golang?
The things about them doing duals is that you can use one to implement the other. So you can use the actors to implement the channel style communication and vice versa. And you're right, like we have the process identifier and we send a message, but we also have what we call name registries. You can go like the yellow pages of process. Maybe I should not use that as a reference because it's going
It
to
would have
be
worked in the 90s.
outdated.
I mean,
yeah. So a process can say
it's
like
your Facebook contact list. Wait, Facebook's too old.
yeah.
TikTok
So
contact list.
it's like, the process can say, hey, I have this name. So if you want to talk to me, send me the message, right? And then you can also have like dynamic registries. So for example, what you can do if you're building a web application that you want to make it real time, you allow people to connect with WebSockets. You give like a dynamic name. Oh, this is user ID 13. And now, when somebody else is joined, it's very easy for you to say, oh, this person is a friend of user ID 24213, whatever. In case they are online, I'm going to send messages to them. And then you just send the messages to them. And that's it. Just this, you've implemented like a real-time feature all within the Erlang virtual machine. You don't have to bring a separate messaging system. Again, it's going to work in a cluster mode, right? So what you would usually use like external infrastructure for, it's very easy to do it within the Erlang virtual machine. So yeah, you also have the name registries kind of thing. And what is really cool is that I love to use this example. So in Erlang, you have a module named global. And usually when we're thinking about programming languages, we say, oh, what is something global, right? You think like global state in the program, right? But the module global in Erlang is global for the cluster, right? So it allows you to register a name that is unique in the cluster. So the cluster is like, okay, in those 5 machines, only one process is going to be named José, right? And then when anything happens, you can route to that particular process. So yeah, a lot of is built like we have those building blocks and a lot is built on top of it.
Yeah. Okay. Yeah. Let's talk about this idea. This is so fascinating to me, especially as a Go programmer. So for anyone that's worked in Go, we use Goroutines, we use channels. And, for example, we deploy our boot.dev backend in Kubernetes. And at any given time, there's probably like 3 to 6 pods of our main like API server running. And they actually don't communicate directly with each other. We have the way they communicate if they need to is like through a pub sub system, very similar to RabbitMQ, which is built in Erlang. But the point is like they have no shared anything. Like there's no shared memory. And it's not like I can publish to a channel and have a different pod on a different machine read from that channel. There's no abstraction layer. But if I'm understanding correctly, in Elixir Erlang, there is an abstraction layer within like the language's standard library API, whatever, that handles cross-machine communication, almost like I can publish to a channel, I can read from a channel in Go, but now it's happening across like physical hardware.
Yeah, it's so in order to build on your example, in your scenario, so the Erlang virtual machine, it doesn't have node discovery in it. So you need to say, look, in this IP address, in this network, there is going to be an Erlang instance, which is great with Kubernetes because Kubernetes is going to give you exactly that. You can go to a Kubernetes endpoint, or you can just do like a DNS query, which Kubernetes also set up for you, right? You say like, oh, what are all the machines that are running my web server or like my backend? I do a DNS query looking for the backend in a particular DNS. It returns me a bunch of IPs. I do that query. Each node can do that query like every 30 seconds, every minute. And then as nodes come up and down, they are going to join the cluster. They're going to leave the cluster. All you have to do is that thing, is those 10 lines of code, which is like, query the DNS, give me the IP, tell Erlang to connect. And as soon as you tell Erlang to connect, then everything else is handled by you. Like Erlang is going to do the connection. There is a cookie which you use for kind of like authentication. So the cookie needs to be matching, but it does the connection. And now processes from those things they can communicate transparently, and you're not really worried about that, right? So for example, one of the features that Phoenix has, and there's really like no, as far as I know, there is no other web framework that offers this out of the box, which is multi-party presence, right? So if you're, imagine like on boot dev, I don't know if you have the possibility of doing courses as a group, right? So
Okay.
if you want to be doing as a group, what you're going to have is that you're going to have, maybe we are doing a course together. I'm going to be connected to a node. You're going to be connected to another node, right? And then maybe you disconnect in that other node. How you're going to deal with this state, which is by definition like a cluster state, right? It's spread out around the cluster, right? And then I've seen like people trying to implement this with the database, but it's really, really hard, because what happens is...
This is what we use PubSub for. But like, again, it's an external system that we have to hook into to get this kind of real-timey event management.
Yeah, but how, for example, how do you know if somebody is still alive? So you wait for them to send like pings for you, and then if you don't receive a ping in time, you consider they are not there.
Yeah, to be fair, like we don't... just because of the nature of boot dev, we actually don't care. So we'd have to do something differently for that. We essentially, all we do is like have to broadcast events to each other.
Yeah,
and then, if they're dead, they just don't get it.
Yeah, if you're doing a messaging, then the fire and forget is fine. But if you're like, hey, who is online right now? Like that's not a trivial, like who...
You need to show a green dot, right?
Yeah, right? Like it's something that feels it's simple, but it's not simple at all. And then if you're like, oh, I'm going to keep this in the database. Well, if that node goes down suddenly because of an error, who is going to clear up all the users that were on that node, but you did not have the opportunity? So it's like, it becomes such a complex problem because it is a distributed problem, right? And then when you're trying to centralize it in any way by putting it into a message queue, putting it to a database, you just make the problem harder because it is a decentralized problem and you're trying to centralize it. So, with Elixir, it's very straightforward, right? Because you're like, oh, okay, I am in this group, and when a new node joins, it asks the other nodes, who is running in your cluster right now? Send me the information. They synchronize, that user is up to date, and now as processes terminate, they receive the messages, and we are all happy. It works, right? So for us, it's a feature that we offer out of the box. Nobody else offers them, right? And it's just like, you don't need to bring an external tool, right? So something that we say a lot, like when it comes to Phoenix, right? Like Phoenix, and we say Phoenix and Postgres, it's all you need. Phoenix in your database. You can bring MySQL if you want as well. SQLite, right? But that's all you need.
We'll take MySQL, right? But bring Postgres.
Yeah. So because if you take everything that you can do with Postgres nowadays, with all the extensions, and you have this amazing technology that allows you to do everything else that is distributed and concurrent, right? You can go really, really far with it. And the beauty of it is that we say also it brings operational simplicity, right? It's oh, you're going to deploy to production. Yeah. Just a database and your web server. Don't need to bring other stuff, right? When you're going to develop, right? You don't have to now you have to run this message queue service as well, right? Or you run a mock of the message queue service, which comes with other problems, which is well, what if there's an error in the mock? Now you're just going to find in production, right? Being able to say, when I'm deploying, I'm using two things and only those two things. It's really wonderful.
So I've used a lot of RabbitMQ in the past. It's this essentially this PubSub broker written on top of Erlang and the Beam virtual machine. And it's incredible. It's my favorite one, actually. There's actually a course on Boot Dev called Learn PubSub Using RabbitMQ. So if anyone's super interested in RabbitMQ, they can go figure that out. One thing that's interesting to me, though, is I've always used RabbitMQ in the context of other programming languages. So I've connected to RabbitMQ from Ruby, from Python, from Go. Is it fair to say that if I'm writing, to your point about all you need is Phoenix and Postgres, if I'm writing Elixir, do I ever need RabbitMQ, or is that almost redundant?
Excellent question. So that's something that comes up a lot when people they are joining the community and the ecosystem. And to me, the rule is, does it need to be durable? Which means like, is the state that you are tracking, does it need to be persisted somewhere? Do you need to guarantee, for example, that a message was delivered? Because when it gets, so you could obviously implement it, right? The RabbitMQ folks, they did it. You could obviously implement it in Erlang and Elixir. But when it gets to a point where the thing that you're running needs to preserve a state somewhere in disk, and now you have to worry about backups, restoring that backups, I think going with an off-the-shelf solution like RabbitMQ or even Postgres, which you can use for a bunch of those purposes as well, is going to be... then I would choose those tools when durability becomes a concern. The way I like to phrase this is that a lot of things that they need to be day one. I'm going to use a not nice word. Like day one, a lot of things that are day one, like technical depth. They're like, oh, in order to run this application, we need full bar and bass. A lot of those things in Elixir, you can either not have to do it or postpone it. You're like, no, I don't need it now.
I see.
Right? And I
Like,
think
I'll just do it in memory for now, and it'll be fine.
yeah, like a Go developer, like people coming from Python and Go, they will have a very good example of that, which is like in Python, when sometimes they need to do things concurrency, the first thing they need to do is to push that to RabbitMQ, right? Or to push to something to do that in the background. Even if you don't need the durable part, just because you don't want to block the main thread and all this kind of stuff, right? Where a Go developer will be like, nah, I'm just going to do it in a Go routine, right? I don't have to, right? So that's one example. If you're going from Python to Go, you're like, oh, I can let go of some like complexity now because I have Go routines. And you can think if you're now going to Erlang on Elixir, they're going to have like more opportunities for you to do that, right? So I think that's like kind of one of the point of views. Like it allows you to opt in later to some of the technical depth or complexity. But I also think that it does bring, so developers that have gone from Python to Go, they're going to probably relate to this as well, because when you have like concurrency as first class, sometimes you start thinking about problems differently, and solutions that were not apparent to you, they become much more apparent and easier to design. Oh, I have to talk to 4 different APIs and I can talk to all 4 of them at the same time, right? Very trivial to do it in Go, very trivial to do it in Elixir. So when you have that tool available, you start thinking all the time, oh, all right, I have concurrency. I can use this and this for this problem because it's straightforward. It's very reachable. And the same thing applies here. When you have distribution available, when you have like, oh, I can just keep 1 million WebSocket connections open to the server and have all users of my web application doing kind of things, right? Distributed or not, it opens up a bunch of different kinds of things. Like, oh, you want to do a video upload where we are streaming thumbnails of the video in real time as the video is being uploaded. Yeah, I can do that because I can keep the connection open. I can do the work as I receive the video, right? It means that I don't need from day one to do the upload to S3, which completely removes some of the processing abilities that I can do with that data. And that goes for everything. So it's like you get a richer tool set.
This is such a good point that I really want to emphasize, especially to our newer listeners. So I love that you made the analogy to Go routines, because I experienced this firsthand pretty early in my career. So we were working on a Rails monolith. Sorry to dunk on Rails again. It happens a lot, which is, again, isn't really fair because I've done a pretty minimal amount of Rails. But what was happening was, okay, we got this Rails application. I shouldn't even say monolith. It's a Rails microservice. It does very few things. Like, this is not a complex application. It's part of a larger, more complex system, but it's a very small Rails app. And it had 2 dependencies that I thought were absurd when I first got introduced to the system. The first was one called Sidekick, which is like a Rails way to fire off background jobs. And I was like, wait, this is just a Go routine and a ticker. Like, these are just two things built into the Go language. Like, I don't need to install a dependency in order to get essentially the equivalent of cron jobs working. And then the other one was caching, where it was like, this is a very minimal amount of caching that needed to happen. Like, seriously, like megabytes of data that needed to be cached. And it was like, we were calling across the network to like a Redis instance dedicated to this service in order to do caching. It was like, this is a map in memory. Like, what are we doing? And I'm not saying you can't do hash maps in Ruby. I know you can. I'm sure it was just like implemented poorly. But I was just like, this is like 10 lines of Go code, all standard library. This is something that, you know, to your point, we could have done the simple thing and kind of kicked the can down the road. Because it's not to say that Redis is never a good solution, but like, you probably want caching at much larger scale, not just something you can do like in memory with a map, right?
And with like Sidekick, like we have something equivalent to Sidekick in Elixir called Oben, because sometimes you do need retries, you need the durability aspect, right?
Yeah.
To guarantee that the thing runs, right? So we do have that, but it's like, so I have seen like in my experience using these other stacks, like people, they bring in Sidekick because they had to call to a service that had to do like some credit card processing, and they had to move it off the main thread because of scalability concerns, right? And that's something that you're like, like credit card today, it's like, it's not like you completely hand off, right? It's a back and forth because you put the credit card and then there's the authorization. I think it's like SOC 2 in Europe, where you need to go back to the user and come up with the things, right? So they were forced to like, oh, now we put this in this queue, take back from the queue, put it back, try to pick it back up, put the user on the page. If you could just do the thing right there, right, it would be much easier. And the thing about this is that it's really hard to convince like people how much difference it makes, because they haven't. It's like, you know, it's like somebody's carrying like 20 kilos on their back every day, or pounds or whatever, right? You're carrying something heavy, and then you're like, and then I come and say, oh, I only carry half of that, right? And I'm like, it's fine. I carry 20 kilos every day. It has been fine, right? Like, they have an experience like having like half of the weight of her back, right? And then as soon as you experience that, you're like, oh my God, like why was doing that for so long? And your point to caching actually comes back to concurrency as well, because if you don't have a good concurrency model, like in Python and in Ruby, right? Like when they are deploying to production, if you have a machine with 8 cores, they start 8 operating system processes, 1 per core. They cannot have one process efficiently using all the cores of the machine because of the global interpreter lock and this kind of stuff, right? Which means that, so imagine that you have 3 machines, each with 8 cores, right? If you're using Elixir, if you're using Go, we are going to start 3 OS programs. And if we say, look, we are going to cache in memory, we are going to put that in a hash map. When we do that, the chance of you hitting a cache is going to be 1/3 if it's caching on a machine, right? So worst case scenario, you compute that cache 3 times, 1 per machine, right? But if you're using Python or you're using Rails, right, because it's 1 operating system process per core, you're going to compute that cache 24 times, right? And they're like, I can't do that, right? I can't do that. I have to put that on Redis, right? And now you are exchanging something that is meant to be a memory access, which is something really, really fast, to a network access, right? While you don't need to, right? So there are a lot of those things where it comes that, you know, like, it's really hard for you to say, like, oh, like, it's so much better. And again, like, it's not because, like, I'm obviously biased, right? But it's like, I was there, right? And when I came here, it was like such a relief. I was like, oh, I don't need this. I don't need that. This is amazing, right? For me, like, the whole appeal of Erlang is like, so I started looking at other programming languages to learn more about concurrency. And the thing that attracted me about Erlang was exactly that. It's like, wait, are you telling me that when I learn concurrency, I'm also going to learn distribution kind of for free because it's the same model, right? And also fault tolerance, right? For me, it's like, that's the combo pack. I want it, right? I want in terms of like learning experience, that's going to be like the best return over investment, right? And this comes like to interesting discussions in the community because people are like when you are learning Elixir and then you start learning about concurrency, like you don't have necessarily need to learn about distribution, right? You have to learn about distribution. You start thinking about how things can fail, right? People are like, well, that there is definitely a learning curve on that, right? Because you have to learn those principles where in other programming languages you wouldn't necessarily have to, right? But the thing is that if you look at the whole curve, we are way compressed with everything else. Because if I want to learn how to do all those things in Go, I have to learn Go. But then I have to learn something completely different for doing that, for doing the distribution aspect. And it's also like the same, like about fault tolerance. At the beginning, when we started thinking like, oh, how about software can fail? So sometimes people, they're like, wait, I'm looking at this code, but now it can fail and I don't know what to do. But when I was writing, I don't know, like Python or JavaScript, I didn't have to think about this. And what they're saying is like, so I would rather go about like JavaScript. And they're saying, no, like the JavaScript code would have crashed, would have gone in the exact same way. It would, all those things that we were talking about, it could have happened there. The benefit of Elixir is that it's actually allowing you to ask about it, right? You're like, oh, wait, this thing can go wrong, right? So it's not like, in a way, it's kind of like we can do like a comparison with a type system, right? Where the type system is like, oh, have you considered this case? And then you look like, oh, I didn't consider about this case, right? And having idioms or fault tolerance being such an important part of the language is also going to highlight cases and scenarios that you wouldn't otherwise.
Your analogy of someone kind of carrying this 20-pound weight on their back. I can imagine someone like lugging a boulder around, right? Like doing all this extra work they don't need to do. And then you take the weight off and they feel relieved and they're so happy. My experience has been that a lot of people come to love that rock that's on their back, and they probably like draw a face on it and it's their friend and they call it Bob. And when you take it away, they get really sad because they're so used to doing everything with the rock on their back. And I'm sure I'm guilty of this too. I think we all to some extent are, right? Like we love the way that we're currently doing things. And so when you take away what can be perceived as a burden, some people will say, of course, no, I love doing it that way.
About the rock, I have like this theory that like most communities, they end up like closing on themselves. So it's like, so I like to say like, imagine that I took a feature from Elixir today and it's a feature everybody loves, everybody appreciates. So like we have this feature called protocols, is one of my favorite features in the language. If I took it off from the language when the language began, right? And now 10 years later, I'm like, hey folks, I've learned about this feature, protocols. It would allow us to write like some amazing Elixir programs. And I propose, people would be like, no, we don't need it, right? Which is, and this works like both for features, both for flaws. We tend to
the Go community is famous for this, by the way, like fighting generics for many, many, many years.
Right? Yeah. So, and I think in some ways, it's natural, right? Like that's probably expected. We are all going to, people probably came to Elixir because of the features that are there, right? So that's very expected. But I think I don't like that, right? Because it means that we are, and of course, like there are some things like if you come and ask, oh, let's change Elixir syntax. There are some things that are clearly not going to happen, but I don't like that it's very easy for us to just close on that and miss opportunities and miss like interesting and important discussions because we got attached to Bob, to the boulder.
Yeah, that definitely happens. I'm guilty of it. I think everyone is. We get stuck in our ways. We're used to doing things the way we're doing them, and it's friction and hard to change. Here's a question for you. You used to do Rails a lot, and then you made a new language, Elixir, which of course you love. It's your baby. Are you still like friends with DHH? Do you know DHH? How does he feel about you abandoning the Rails ecosystem to go build your own thing?
I'm not. No, like we're not friends in the association of the word being friends. I definitely know him. We definitely interacted when I was in the Rails team. I've my passage through Rails was like very big like learning opportunity for me in terms of
Mm.
like how to deal with community, like because when I joined Rails was uh it was like I believe still at the when Rails was at its peak in terms of like people talking about it and people joining the community. A lot of like experiences learning that, and and not only from the HH but from the whole core team. So yeah, I have very little contact with Ruby and
Okay.
Rails nowadays. I was invited to go to the European Ruby conference this year after I think 8 years, and it was really nice, really nice. I
Let's talk about
love.
Elixir.
Yeah, they invited me to talk about Elixir, and I love talking to Mats, the creator of Ruby.
Yeah.
He's one of the, I think, when he gives a talk, I always come back inspired from his talk, like inspired to be better, to do better. So I always appreciate his talks and how he leads the Ruby community with a lot of grace. So yeah, there is still like some. Sometimes there's something here. I still have some friends in the Ruby community, but it has been quite some time that, I have
Yeah.
like participated
Makes
in.
sense. I mean, you're
Yeah.
focused on a very different project now.
Yeah.
I say a lot of shit about Ruby on Rails, which I try to always caveat, which but don't listen to me. Like, I don't actually know enough about Rails to be criticizing it the way I do. I just have been scarred by a few experiences of, old Ruby code bases and porting them to Go and then everything being happy afterwards. But there's a lot of bias there. Like, legacy code's always shitty. Even Go legacy code is shitty. And so I would love to have DHH on the show. I promise I'll be nice. But
Well,
that's
I
cool to
think
hear that. Yeah.
I actually like you say I'll probably be nice, but I think like even if you bring your legit concerns uh and bad experiences, I'm pretty sure the HH is going to have good and valid opinions on that as well, and good insights. So I'm saying like you don't have to promise to be nice,
Oh
and
yeah.
I'm sure he'll take it really well as well. So
No, I've heard DHH on so many podcasts. Yeah, have crazy respect, even not just for like his work on Ruby on Rails, but also like Basecamp and the 37 Signals stuff. Like they have like such a good business and entrepreneur person as well as, framework maintainer. But anyways, enough about DHH. DHH is great. Enough about him. We're here to talk about you. Uh, cool. So we spent a lot of time talking about like infrastructure level Elixir, distributed system, Erlang stuff. And I know we're getting close here on time, but I want to give you just a chance really quick to plug maybe like your one or two favorite like or not Erlang, Elixir specific features, like language features, that might get people excited to come check it out.
yeah, so I'll answer that soon, or maybe I'll answer half of this question. One of the features, which is I want to try to wrap it all up. So
Yeah, go for it.
at the beginning, we were talking about Elixir being a functional programming language, right? And I was saying like, well, when Elixir is a functional programming language, maybe it doesn't have a Hitler linear type system, so maybe it isn't. But we would say it's a functional programming language. And I also said that when people mention functional programming languages, Erlang and Elixir, they do not necessarily come up, right? And I think like at this point in the episode, it's kind of clear what they not come up, like, because the things that we are focusing on is like, well, I want to build a concurrent and a distributed system, right? That is fault tolerant, right? And so it's like, if you think of a tag cloud, here I am showing my age again, right? But if you're thinking like of a keyword space, like those are the words that we are kind of embedding ourselves into. But the one thing that allows Elixir and Erlang to kind of make a claim that they are functional is also the thing that powers everything we have been talking about today, which is immutability, right? So I want to talk about, so in terms of like favorite features, I think the feature, the GOAT of the like Elixir of the Erlang virtual machine is immutability. And the idea with immutability is that if you have a data structure in memory, you're not any wanted to change something in that data structure. So if I have a list, or an array, and I want to remove something from a list and array, we don't go and we change it in memory. We get a new list, we transform it. So instead of mutations, we are now thinking about transformation. We get a new list without that element. So all the built-in data structures in the language, they are immutable, right? So maps, which are equivalent to hash maps, dictionaries, right? Lists, tuples, right? Everything, strings, everything is immutable, right? And the reason why that is important, so the reason why it powers it, you get, I think, 4 features. I think I can talk about 4 features when you have immutability. So the first one, which I actually learned with time, when I started this, I did not actually know this, but it's maintenance. Because we have all written this code where we have an object or something, and then we call a method in it, and then you pass like another object as argument, and then that object modified the object that we were passing as argument in a way that we did not expect it. We all had to debug this code. We're like, wait, there was a key here, but it disappeared. Who removed the key from this dictionary, right? Who removed the thing, who mutated my list, right? And the idea with functional programming and the idea with immutability is that, look, because you cannot mutate the data structures, if you need to pass something to a function or a method, and that thing needs to change that thing, it needs to explicitly return the change thing as an output. And this is beautiful. This is absolutely beautiful, right? Because I can look at the code and the code is always clear. Oh, this function needs this and this and that to work. It's being passed as argument. Oh, this function needs to return this and this and that. It's there in the return type. So we were talking about boulders. That by itself, me like not having to worry about, hey, when I call this thing, is it going to change the arguments or not? Right? Like that's a huge burden like lift off our back, right? I like to say like now when I have to go back to usually imperative languages, it's like programming in paranoid mode. I am insecure most of the time because I'm like, I'm going to call this thing, but what is it going to do with the world around it, right? Like, what are the things that is going to change? What are the objects, right? And then immutability allows us to ditch a bunch of those concerns and like, okay, everything's clear. Inputs and outputs is going to be clear, which is something very common in functional programming as well, right? So the first one is maintenance. Immutability is going to give you, I can argue that confidently, is going to give you better software maintenance because it's going to make it much clearer to understand. The other thing that immutability gives you is that it gives you a better foundation for writing concurrent software. Because, so for example, when I started searching for concurrency was because I was dealing with data races in Ruby. We were trying to write concurrent Ruby software. And now what you had is that you have 2 threads trying to change the same place in memory, right? And then if you don't have a global you can add a global interpreter lock, but that makes things slow, right? Or you don't deal with that, and then you have segmentation fault, or now you have to learn about threads, mutexes, make sure that 2 different pieces of code is not going to change. But if your data structures are immutable by default, a lot of the issues with data races, 2 things trying to change the same place in memory, literally cannot happen, right?
Yeah.
Is that to say that you don't have any immutability in Elixir? Of course you have. We have things like high performance counters for optimization that are mutable, right? But the default, by large is immutable, right? So this is great.
Yeah.
We are getting maintainability, and we are getting concurrency out of that. Like way easier concurrency. There are less things for me to worry about. The third thing that you get is also the fault tolerance aspect. And we've hinted at this, right? Like imagine that you have two Go routines, right? And now those Go routines, if they have some shared state, right? Imagine that one Go routine crashes, something goes wrong. What can you assume about the other Go routine if they're shared state? You can't assume anything. You don't know if, like, when this Go routine was corrupted, if it left the state in a good place or in a bad state.
Yeah.
Like, it, now
if
you
it's
have to,
depending on like a reader or a writer or something, then the other one effectively is like blocked and useless.
yeah, right. So the shared state, like when you think about like fault tolerance, oh, I want to have like parts of my system that restart. Shared state is a liability, right? Because it means that whenever you have shared state, when one of those things crashes and they have shared state, the safest thing for you to do is to assume that they're all bad, right? So the more shared state you have, the less, let's say, like, the harder it is to make that code fault tolerant, or to make that. It's not that it is impossible, but it's most like, going back to the boulders. Like if we assume that the state is not shared, the restarting thing comes for free. But if you have shared state, you have work to do, right? Now you have to check, double check, triple check, write the tests, right? So again, so immutability, you don't have shared state, right? Getting the fault tolerance aspect is very, very important. But it's also the thing that gives you distribution, right? Because if you have shared state, right? What happens now if I have two processes that are collaborating and they use shared state? Well, now they are across nodes. How you're going to have that shared state across nodes, right? But again, if you're writing the software with the assumption that the state is not shared, if you need to communicate, you're going to send a message. Writing distributed software is going to be much easier. And again, like, it's not that you necessarily, sometimes you're lucky, you write the code to, you write your Elixir code to run concurrently, you're like, oh, I want to make it distributed. And then you just flip a flag, say, oh, now run on that node, and it works. Sometimes you're not that lucky. But it's the difference between me doing 1 day of work to get the distribution feature working compared to weeks or months, right? I know, because
there's no world in like my Go code where I'm even close to being able to just run it distributed. Like it's gonna be a whole rewrite or a whole, cementing of extra features on top to make that work.
Yeah. So, when it comes to favorite feature, and now it goes back, right? I think it's immutability. So for me, if you're talking about functional programming, for me, what I really care about in a functional programming language is immutability. Because if that's the driving principle of the software, you get so many properties from it that, that's the key property that I'm looking for.
That makes a lot of sense. I don't program in a a purely functional programming language full time, but I can confidently say that my favorite feature of functional programming is my favorite idea or paradigm is pure functions, which is a direct derivative of immutability, right? The idea that inputs don't get mutated. My functions are pure. They're black boxes. That's my absolute favorite thing. My next favorite thing is typing.
Yeah.
So we're getting there though.
Yeah. So the idea of purity, which is what a lot of functional programming languages are going to bring, is a superset of immutability, because purity is going to include I/O operations as well, right? So you cannot write to a socket, right, or read from disk. The function would have to display.
So does Elixir not enforce that level of strictness?
No, we don't enforce purity. It is one of the cases. So that's a boulder that we carry, right? So, in the sense yeah, I'm pretty sure.
I kind of like that. I don't know. I've always felt like a lot of functional programming languages take it way too far to the extreme, because I/O is so fundamental to everything, at least that I do on a computer, that kind of trying to hand wave it too much and put it in a corner too much results in issues. So sorry, go on. I cut you
No,
off.
no, no, no. Yeah. No, I think it's exactly that. I like that. I think it's a very pragmatic approach. And the other thing is that the I/O in Elixir is done by message passing anyway. So it's not like kind of like, oh, you're writing 2 bytes willy-nilly kind of thing. We have some abstraction and observability around that, right? So, but we don't track it. Like you can do it from anywhere, right? You can do it from anywhere, which I agree it's a positive, but I'm also saying like a purely functional programmer could be looking at us right now as like, they chose to carry this boulder. And if they took off their backs, right, they would know how better the software is, which is fair, right? But, so we care about immutability. Yeah.
That's fun. Yeah. I love that take, actually. I like the idea of immutable by default. It's going to lead to a lot of your functions being pure unless you're doing IO. But like, it's important to point out that like, I've worked in a lot of languages. Like, for example, just in my daily work in Go and Python, I have to constantly remind myself and my team, like, hey guys, when a function can be pure, let's make it pure. When something can be immutable, let's make it immutable. We have to go to that extra effort to do it. A lot of times, and you know, of course we just do IO wherever it's convenient. I mean, we try to isolate it to like keep it sane, but I love the idea of like, if you're not doing IO, it's kind of just pure by default because at least the immutability aspect is enforced.
Yeah, and then if you do I/O, most of it is happening through message passing, and you do have this great amount of visibility into it, which I think it's important. So yeah, and again, like a lot of the things that we talked today, it's really, they are all from Erlang, right? Those are not Elixir features, right? So those are not ideas that I came up with or things I created. It's just Erlang, right? And Elixir running on top of that and leveraging all of that.
Yeah. Amazing. Thank you so much for coming on, Jose. Can you tell everyone, I want you to plug any and all of your projects and educational resources where you want to send people who are listening to this podcast so they can learn more.
Yeah, fantastic. So on the Elixir website, we have we have links to documentation. We have, I believe, a learning page where you can find books, videos, and all this kind of stuff. So I recommend, if you heard or if you listen to this podcast in any way, you want to try it out, check those resources out. There is a book called Elixir in Action from Manning that people really love it. There is also a talk from Sasha Urich, The Soul of Erlang and Elixir, which also talks about a lot of things that I mentioned today through a different angle. Good resource to share as well. And the one last thing I'll plug is livebook.dev. I mentioned it. It's a code notebook platform where you get to write Elixir and document at the same time. It has a lot of features in there, but if you want to start learning Elixir and you want an environment that is going to give you really quick feedback and allow you to play with different things, it's a great tool for getting started and learning more.
Amazing. Awesome. Thanks so much, Jose. We'll talk to you later. I really appreciate you coming on. This was a fascinating talk for me, and I've got a lot of research to do on Elixir.
Yeah, thank you for having me.